Hi, my name is Erica Voss, and I'm together here with Clair Blacketer, and together with Frank DeFalco, Maxim Moinat, and Peter Rijnbeek, we're going to be talking about data quality dashboard used to improve data quality in the EHDEN network. Now, in 2018, the European Health Data and Evidence Network public-private project was launched, and this project was to address current challenges generating evidence at scale from real-world clinical data. EHDEN's vision is to be a trusted research ecosystem to enable better health decisions, outcomes, and care for patients. Now, one of the foundational pillars that EHDEN uses to realize this vision is to generate a federated data network. And the way this works is institutions that have clinical data will convert their data to the OMOP Common Data Model. They will maintain their data within their own institutions, and then EHDEN can act as a broker to share standardized code along with a protocol that data partners can choose to participate and send back aggregated results. Because everybody is standardized, we're able to perform network-based research. However, because the data can stay within the individual data partners, they can maintain local governance. Now, just like we do in OHDSI, EHDEN follows the standard conversion process where we summarize the source data, create an ETL design, implement that ETL design, and then perform quality assessment. During our quality assessment review, we're probably going to find issues. And so we'll go through the cycle of fixing the ETL and assessing quality until we feel that we have a high quality CDM. At that point, we're ready to perform research. Now, assessing quality is really important part of this process, and one of the backbones of assessing data quality is the Data Quality Dashboard, or DQD for short. DQD is an open source tool that assesses and communicates quality of an OMOP CDM and has over 3,300 data quality checks. DQD provides a systematic approach to assessing data quality. Now, in OHDSI, we assert that this is the way to assess quality issues and deal with them within your OMOP CDM. However, we never reviewed this at scale, and EHDEN was going to provide us an opportunity to do this. In early 2020, when the COVID-19 pandemic started, EHDEN held a call for data, the COVID-19 Rapid Collaboration Call, where EHDEN was going to provide grants to data partners to convert their data to the OMOP CDM. 75 data partners applied and 25 data partners were awarded a grant. Then we were able, of those 25 data partners, to ask them to run DQD when they had their first CDM, and then run DQD when they had their final CDM, to then understand what were the differences over time. Ultimately, we want to be able to answer the question, does DQD improve quality of an OMOP CDM, thus improving our trust in the EHDEN federated network?
So of those 25 data partners that Erica mentioned, at the time of our analysis, we had final results for 9 of them. So you'll see here on this graph that each grouping of 2 bars represents 1 data partner. The bar on the left represents the first DQD run, and the bar on the right represents the last DQD run. Now, when you look at these 2 bars, the blue portion represents the number of passes, the yellow portion, the number of errors, and the orange portion, the number of checks that failed. So you can see between the first and the last run for each of the 9 data partners we assessed, they all had more data quality passes in their last run than in their first run. So part of this experiment, we were also interested to understand which data quality checks failed most often in the first run compared to the last run of the data quality dashboard. So you'll see here some check names on the left-hand side. These are high-level aggregates of how we define the data quality checks that are run. And then you'll see the percent failures between the first run and the last run. And for all of these data quality checks, there were fewer percent fails in the last run than there were in the first run. But what was interesting to us is that some of these, like the plausible temporal after check or plausible during life, are related to the source data. So in this example, you'll see that one data partner had 81.5% of their visits for people with a date of death ending after that date of death. This ended up being a problem with their source data, so they went back and addressed the problem. And in their final run, you'll see that this 81.5% went to zero. So this is an example of the issue with the source data, but there were also issues with how the data partners' data conformed to the CDM. So in the next example, this data partner, for 62% of their records in the measurement table, they had a unit concept ID of 0. Now this is related to how the text value of a unit was automatically mapped to a standard concept. They went back and did some manual mappings, and they were able to reduce that 62% down to 7%. Now you'll see this is still listed as a failure here, but that decrease from 62% to 7% is the exact type of improvement we wanted to see. So what came of this? What were our conclusions? What we found is that all 9 completed data partners showed improvements in the number of checks passed between the first and the last run of the DQD. Now what we can see is that we can begin to use this data for research. Of course, you'll still need to run data quality checks during the course of a study, but we can be confident that the larger compliance, completeness, and plausibility issues have been addressed. And as proof of this, several of the data partners we actually showed in our analysis participated in an inaugural evidence-a-thon, where we all got together and worked to generate evidence using the same package. And what was really nice is that, due in part to this work, all groups were able to focus and participate in the science rather than worrying about their data quality.